Good day everybody, welcome to today's session. Within the next few minutes you will know exactly how to use the Watchdog timer. I'll also give you some sample code that you can start off with. Now the function of the Watchdog timer is to make sure that your program is running, and as soon as it hangs, or if there's something, if it doesn't reach the next command, then it will do a software reset on your program. So let's have a look at the code. Now there's a few command lines that you'll use when using the Watchdog timer. The first one, Watchdog timer enable, you can set it to 1, 2, 4 or 8 seconds there, and then you will have your reset command. The reset command must be used before that 1 second or 2 or 4 or 8 seconds are reached, and then you can also disable and enable the Watchdog timer whenever you like. The next thing that you will include is your Watchdog timer library in your sketch. Here you can see I've got a blank sketch, and we're just going to do a little bit of programming with the Watchdog timer here. And the first thing is in your setup. Now if you're going to use your display, then you need to first set your baud rate for that. So let's put that in there, and we'll use 9600. Then the next command will be your Watchdog timer that you enable. In this case you will see that the Watchdog timer is enabled, and it's for 1 second intervals. And then I'm just going to add another command there. And this is so that it will print to the screen whenever the setup is run. So I will be able to see when the Watchdog timer resets this program, and the program restarted will be printed on the print screen. Right, so here we've got it. Now at this moment in time we do not have the reset command in the main loop. Nothing happens in the main loop. So what we will expect is that after 1 second the program will be reset, and that program restarted will be printed on the print screen. So let's let's compile and upload our program. So it's compiling at the moment, and it's uploading. You can see it uploads, done uploading, and we can open our serial monitor, and you will see there every 1 second the program is restarted, the setup part runs again. Right, so now we're going to add this reset Watchdog timer into our main loop, and what will happen is, because this will run all the time, it will be reset all the time, and we should not have a problem. So I'm compiling and uploading it again. And what we would expect now on our print screen monitor will be that the program restarted will only be printed once, and after that the Watchdog timer will be reset, and the program will not reset. So let's open our serial monitor, and there you can see it. Program restarted. It ran the setup part only once, and after that the Watchdog timer is reset. Now if you put in a delay, let's make the delay, the Watchdog timer is set to 1 second, so let's make that delay 2 seconds. That would mean that this delay is longer than the reset time. So this command, the Watchdog timer reset command, will not be reached in time, and the Watchdog timer will then reset this program. And because in the setup there's this print command, program restarted, it will be printed all the time. So let's compile and upload that. So it's busy compiling at the moment, and yes, it's uploading. Right, let's open our serial monitor, and you will see here, because of that 2 second delay, the program is restarted every 1 second because it doesn't reach this Watchdog reset command. Right, now as you can see, this can be a problem when using the Watchdog timer. As soon as you've got a delay that's bigger than the Watchdog timer setting, then the next reset command will not be reached in time. So there's a way to move around that, and I'm quickly going to show you that. So we will use the moles function in the Arduino IDE. And I'm just going to copy some code here into our main loop, and I'll explain it just now. Now we've got two variables, start moles and current moles, and we make them equal to the moles. The moles is in milliseconds where the processor is at that specific moment in time. So we can say start moles is equal to moles, and current moles is also equal to moles right beneath each other. Right, because these are two variables, we must define them at the top, and you use the type long for them. So we go at the top there, make some space, and we will put them in start moles and current moles of the type long, those two variables. Right, so now what happens here is after you've made the start moles equal to the moles at the moment and the current moles equal to moles at the moment, you start with a while command there, and you say if current moles minus start moles is smaller than the time period that you want to take for that delay, and let's keep it at 2 seconds. Let me just remove this delay at the bottom and delete some lines here. Alright, so what happens now is that as long as that 2 seconds have not passed, this while loop will execute. The while loop consists out of a reset command for the Watchdog timer, and we're also updating the current moles with the moles that the milliseconds reading that's at the moment in the processor. So as long as this is smaller than our time period, which is 2 seconds in this case, then this loop will execute. After that, it will go on to the rest of the main loop, and the main loop will repeat. So now you can see we've got a 2 seconds delay. We reset that Watchdog timer inside the 2 seconds delay, and it should work. So I'm compiling the sketch. It's uploading, and we can just open our serial monitor, and you will see that the program restarted once. That was in the setup, and it's not restarting again, although we've got a 2 second delay in it. And at this moment the Watchdog timer is set to 1 second. So that's the way that you can then use that. I hope this video helped you a little bit. This code will be in the first comment below the video. Thank you for watching. Bye bye.